All right, so we are getting into the fun part of physics here, where we actually get to start conducting our own labs. So I am going to show you an example lab today of me working through all the little steps, all the little pieces. This is going to be a longer video, but you're not going to have as much to do. Okay. This is also the big setup for the lab that you are actually going to be doing on your own starting tomorrow. So our real life speed lab, and specifically quarantine edition, because that is where we all are, we have limited resources. Obviously, I can't take you into the school and give you all sorts of materials. We're going to work with what we've got. So my quarantine real life speed lab is going to be the cats, Reggie and Brooklyn, versus Nala, my brother's new puppy. So since this is a lab, we are going to actually be using a few of our scientific method skills and some tools that you might not know you have access to at home to help you get going and actually do your lab. So why don't we start off with our question and our lab setup.
All right, hello. Today we're doing something a little different. So you have just finished reading on calculating speed, and you've practiced that. So today what we are going to do is we're actually going to set up a little lab. Now, I'm going to set up a lab as an example. All you're doing today is figuring out, okay, what's my lab, and then practicing calculating speed from that. Now, Thursday, shortly after, you are actually going to be making your own experiment that could be pretty similar to mine, could be a little different. You have a lot of freedom here. Usually we would do a lab like this in the classroom. I would use human volunteers, but I am going to use what I have on hand, and that is my cat and my brother's new puppy. So I'm going to move that so it stops rattling on the ground. We are going to test today who is faster, my cat or my brother's puppy. I will put in a picture here of his new puppy so that you can actually see what it looks like. She is adorable. So in order to find speed, we have just gone through how to calculate it. So speed is equal to distance divided by time. So we know in order to find which is the fastest, we are going to have to know how far they went and how long it took them to get there. So it doesn't matter if we have the same distance for every object or every, in this case, animal, because as long as we do this, we're going to get the same speed. Now, we have 3 different participants. We have Brooklyn, we have Reggie, and we have the new puppy, Nala. So
I'll just put in parentheses, cat, dog. All right, now would be the time to make the predictions.
Who do you think is going to win? Who's fastest, the cat or the dog? So, here are our different objects. I'm going to make a quick data table. All right. So, we know we're going to have to calculate speed each time, but more specifically, we're going to need to know distance over time. So I'm going to leave a little bit of space. Trial 1, trial 2, trial 3, and our average. All right. Sorry, I believe my iPad is making a strange noise right now. Okay. All right. So, trial 1, trial 2, and trial 3. All right. So I'm going to get this set up, and then I'm going to come back to you. I'm going to show you how you can actually use materials that you might have at home to calculate this. One thing I am very fortunate to have, I remembered to grab a meter stick before we got kicked out of the school building. So I will be measuring in meters, but I will actually show you a quick clip of how you can use your iPad to measure distance. And you can set it up between those 2 areas and then measure it afterwards. Yeah, let's go ahead and get to it. Oh, the other materials I have. Obviously I have this. You guys will have the numbers app on your iPad. I'll actually probably kick this video out to explain everything for you so you can actually see me writing on mine. I have some way to measure be that a meter stick, a ruler, if you have a ruler laying around, if you have a yardstick at home, you can do that. If not, your iPad is actually going to work just fine for this. Some way to collect data, and then whatever you need to get your things to go. So you're going to need a couple different things. I have 3 animals, 3 different types of things. But whatever you need to make them go. So for example, Nala, the little puppy, needs my brother to run. All right, I'll check back on you soon with our actual data collection.
All right, so I apologize. My iPad actually was making very strange noises. You are going to be using this table right here. Let me get out my lightsaber today. Okay. You're going to be using this table here to collect and record your data. This is the same table you're going to be using over and over and over again. So when we practice collecting speed, you'll use this table. When you go to collect your data, you'll use this table. And I made sure my table looks exactly like yours so that it's very familiar for you when you go to collect your data. The other thing to show you is just how I set my lab up. Now, obviously, I am self-isolating, meaning I am not near my brother. He actually lives in Illinois with my parents right now. So he is down there, and I set up my lab differently than he set up his, and you'll see clips of both. But here is how I set up my first part of my lab.
All right, so I don't think you can see me because of the cat. I have set up somewhat of a little racetrack here. So over here on the ground, I have a blue meter stick. Move the cat out of the way. Woo, there we go. I have a blue tape mark, and I have just marked off 3 meters. Coming over here, where I have my final meter mark, and then here is my reference point for you guys, since it's going to be a little bit difficult to see. Here is the end line. Now, I don't know if you've ever tried to make a cat chase something, or made a cat run in a straight line, but it is terribly difficult. So, that being said, I originally started with 5 meters because I thought that was an easy number to work with. However, I am finding that that is way more challenging, as you can clearly see by Reggie taking up the entire camera. So, here is participant number 1, Reggie, and Brooklyn was the one that you saw at the beginning, over here. Alright, I'm going to get the camera set up, and we're going to go ahead and we are going to let them go.
So that actually leads really well into my next topic. So before I start collecting data with you, I really do want to talk you through some of these things. I don't want you to be discouraged by this, because this is a lab. This is something that you will have to go through, and it comes with some hiccups along the way. So first and foremost, trial and error. This lab may take some finagling. I told you that I had originally set out 5 meters. I actually tried to do 5 meters upstairs. I tried to do 5 meters downstairs. I recorded the intro video 4 times. I tried to do a lot of different things, and I found that I was trying to push my circumstances a little too far. It's hard to make a cat run in a straight line for 5 meters. So I shrunk my distance back a little bit, and I got a little bit better results. I also started with trying to make them chase after a treat, which is all fine and dandy until they couldn't see where the treat went. And knowing, because I am working with animals, like, they're your animals if you're working with animals, I know when they work best and when they don't. So I had to make sure I was working around their schedule. This goes for any lab that has any sort of live participant in it. Make sure you are being considerate and kind to whatever your participant is. The next thing is work with what you've got. Your iPad is going to be a great tool for this. It does all sorts of things. It can measure. There is the Measure app. It can record, obviously, with your camera. They also all screen record now. And it can also time. And there's a couple different ways you can time. You can time it during. So as whatever your thing is going, you're able to actually record and like start and stop a timer. If you can do that, that is great. You'll see a little bit later, Miss Jackson, the guidance counselor, Miss Jackson, did that to help record hers. The other way to do it is to take a video and record after, or use your timer after. Now you can do this with split screen, on your iPad. So if you only have your iPad as your device, that works. You can still do this, no problem. If you have a phone and you want to watch the video and start and stop it on a phone timer, you can do that as well. If you actually have a legitimate stopwatch at home, you can do that. There's just a whole bunch of different ways that you can work with this. So this is, this is my example for trial and error. This is going to move everything. I'll show you real quick. This is just a quick clip and I will have it posted later. When you're going to split screen, just make sure both of your apps have been recently opened. So I go ahead and I just open both right away. And then from the bottom of your screen, you can pull up to access your dock and then drag that app out and it will split screen for you. So now I was able to record like start and stop as I watched the videos happen.
Get set, go.
Which is one that you'll watch. And then the other one, I guess I'll just move it up, is measuring with your iPad. So you have the Measure app on your iPad. I'm sorry, backing up. This right here, I did entirely with screen record. So all you're seeing right there is I used the screen record feature on my iPad to turn it on and off so I could see both, and then I didn't have to write it down because I have the actual video. Okay, sorry. Now, you have the Measure app on your iPad as well. It comes default with the iPads, but basically you find a spot when you open it, hit the plus button, and then as far out as you drag, it'll actually measure for you. You can set this up to measure in meters or in feet. You can walk with it and you can make sure that you're getting the actual distance. And then you actually have the ability to like take a picture almost. And as you turn your camera around, since it is like a 3D modeling, you get to see the exact measurement that you have between the two distances. It's not perfect, but for what we are doing, it is very useful. Okay? So that is that. This does not have to be something where you are using animals. I have examples with animals and I have examples with people because that is the kinds of things that the people I was having help me out had. Okay. Feel free to use toys. There's an example in there of my mom rolling a combine on the ground, a toy combine from when my brother was little. If you have toys, those work. Anything that moves some distance. And then finally, ask for help. If you are struggling to get any of the apps to work, if you don't know how to do it, if you can't think of ideas, if you, for some reason, don't have access to some of the materials that I've listed that can help you, please reach out to me and ask for help. It's one thing to do a lab. It's another thing to do a lab virtually. I expect there to be a lot of questions, which is part of the reason I'm going to start holding that office hour time as a video call for questions as well. So please reach out to me, either a personal message in WebEx Teams or an email. Ask for help with this project. This should be fun. It should be a little bit different. But if you need help, please ask. All right, so let's get down to business. I'm starting with Object 1, Brooklyn. I am going to zoom in on my, no, I'm not. There, All right, I'm going to zoom in. There we go. Just so that my writing is a little bit clearer. Shwing. And I'm going to write Brooklyn as my first object. For those of you who do not know, Brooklyn and Reggie are brother and sister, and she used to be the big one, and he used to be the little one, and things have definitely changed. Okay, so I have recorded videos of them running. Like I told you in the last one, this took a lot of trial and error. Some things went really well, some things did not. So basically, I'm going to show you the video of my data that I recorded. Swoop, I'm going to have to move these ones out of the way. And as you can see, I've already used the timer feature, so I'll just let it run through. We'll write down our speed as we go. Ooh, before we do that, I apologize. One more thing. Very important thing. The distance. So the distance that I used for all of my trials was 3 meters. So I'm going to make sure that I am writing in my distance, 3 meters. All right, now let's go ahead and we'll watch trial 1. All right, so from point A to point B, from one end to another, it took Brooklyn 1.42 seconds. So I'll shrink that video up. We have now watched it. And it took 1.42 seconds. All right, trial number 2, I believe is this one. So there's Brooklyn, 1.32 seconds. All right, I am seeing some consistency here. So trial number 2, oops, 1.32 seconds. And then last but not least, trial number 3. Ooh, that one was fast. Laser pointer was that one. That one was very useful. So that one was 0.99. That one was under a second. So I'm going to zoom in again. 0.99 seconds. All right, now to actually calculate my speed, I'm going to take my distance divided by my time. I am not a person, I've told you this before, I'll tell you it again. I am not phenomenal at math. Okay? It is something that I've struggled with. By all means, use a calculator. So I'm going to pause the video right here. I'm going to grab my calculator and I'm going to come back and we're going to talk through it. Okay, got my calculator. So my first one, I am taking 3 meters divided by 1.42 seconds. So type that into my calculator. 3 divided by 1.42 seconds is 2.11, and then my label, in this case, because I have meters and seconds, is meters per second. That was a really sad M. Try to fix it. There we go. Okay. Now I'll do the same thing for trial number 2. 3 meters divided by 1.32 seconds gives me 2.27 meters per second. Again with the set M. If I were to have something like feet per minute, my label would then be feet per minute. So whatever you're measuring in, that label ends up staying the same as what it was before. All right, trial number 3, we have 3 meters divided by 0.99 seconds. And that tells me I have a 3.03 meters per second. All right, so the higher, bring it back, there we go. The higher the number, the faster the speed. Okay, that should make sense. So find our average. I'm just going to take all 3 of our total speeds. So I'm going to take my red highlighter. I'm going to take this one here, plus this one here, plus this one here, and then I'm going to divide them all by 3. So our average, jot it down at the bottom, average is equal to the sum of all the trials. So trial 1 plus trial 2 plus trial 3, all of that divided by 3. And then remember your order of operations. If you're going to do this all in one, make sure you hit enter before you divide by 3, or else you're going to have a really wonky average. So I'm going to take 2.11 plus 2.27 plus 3.03. I'm going to hit enter. So I have 7.41. And now I'm going to divide that by 3. So my average speed, Brooklyn's average speed, is 2, oh dear, 2.47 meters per second. All right, not bad, not bad. Okay, we're going to go ahead and we're going to calculate Reggie's now. All right, now we have object number 2, Reggie, my giant tomcat. I believe I've told you this before. In case I haven't, fun fact about Reggie. Reggie is 3 feet long. So he himself is about a meter. Oh, and that is some terrible handwriting. Yeah, so he himself is about a meter. He is my big cat, big tomcat. Shoo, too far. So let's go ahead and watch Reggie's data. So shoo, there's one. See how fast he goes. So 2.15 looks like our first time. And again, I forgot to write in our distance. Distance for Reggie is also 3 meters. And his time was 2.15. So I'll jot that down. One thing I really liked about having the videos recorded and then having that timer recorded is I never had to go back and figure out what was what and where it went. It is all right there. All right, trial number 2. .12. That one was a little faster. I would not be surprised if when food is involved, this cat is faster than Brooklyn. All right. And our last trial. Ooh, real fast. 0.68. That one, he thought he was getting food. So 0.68 seconds. All right, same thing as we did last time, except for I'm apparently making my chart very large and everything else very small. I am going to take my distance divided by my time to find my speed. So I am going to get my calculator out and I am going to find 3 meters. So 3 divided by 2.15, giving me 1.39 meters per second. And then I am going to take 3 divided by 1.12, and that is 2.67 meters per second. Again, because my label is meters and second, because that's what I'm measuring in. And then finally, 3 divided by 0.68 seconds will give me a speed of 4.41 meters per second. I can tell already that this one's a little bit wider of a range. If you look at my numbers from here to here, that's quite a range, from 1.39 to 4.41. So I expect our average is going to help us even that out. So again, my average, I'm going to take all 3 of my speeds, and then I am going to add them up and divide by 3. So 1.39 plus 2.67 plus 4.41, hit enter, and then divide by 3. So Reggie's speed is 2, oh, not a highlighter, actual pen please. Reggie's speed is 2.82 meters per second. I did not have Brooklyn's speed in here, so we are all going to have to wait till the end to figure out who was actually faster. All right, zoom it back out. And let's see if that cute little puppy is faster than the cats. Okay, so before we do any actual calculating here, I wanted to show you the video of Nala without anything else. So in the middle is my brother. Nala is that little German Shepherd puppy on the edge. They just got her like about a week ago now. Okay, so about a week ago. This again was not something that I could record. I wasn't near them. I just asked, hey, could you record your puppy running some distance and send me the video of it? So then I could do the timers all by myself. I could use the stopwatch just like I had explained earlier. But here is Nala running, chasing after my brother. All right, so that was her. Now the distance is going to be different on this one. My brother measured, because they were running from tree to tree, that was much more than 3 meters. So my brother's measurement, we're going to come over and write Nala in the box so we know whose this is. Nala's going to be blue. So the distance that my brother gave me was in feet. So I am going to need to convert that to meters. Instead of teaching you a really complicated problem and way to do this, or a really complicated math problem to get there, I am going to tell you it is a-okay to type into Google 23 feet equals blank meters. If you have plenty of other things to worry about other than being able to convert from feet to meters. So 23 feet is equal to 7, oops, that's the time box, okay, 7.01 meters. And I can go ahead and I can fill that out with all of my boxes. So 7.01 meters. That was how far it was when they went tree to tree. And last one, 7.01 meters. All right, good deal. So let's go back and calculate and see how fast Nala is. What is her speed? All right, video number 1. That was the one that we just watched. All right, 3.20 seconds. You can tell that I kind of struggled with this the first time I did it. All right, I know it might take some getting used to, and it is a-okay if it takes you a couple tries to get it to work. This is a trial and error situation. All right, so 3.20 seconds. 3.20 seconds. All right, let's check out the next video. Ooh. Trial number 2. I'm gonna run back the other way. .98. I also tried to start and stop the timer, not when the video started, but when the puppy actually started running. That was my way to try and keep things under control. So 2.98. .98. Again, I'm in seconds. And trial number 3. It's a little delayed on that one. 1.98. So 1.98. All right. So let's go ahead and go back through and get our calculators ready to calculate our, sorry, bring that video back, our speed. All right, so calculators out. I'm going to take 7.01, that's our meters, divided by our time in seconds, so 7.01 divided by 3.2, and I get 2.19 meters per second. Go ahead and move on. 7.01 divided by 2.98 gives us 2.35 meters per second. Sad M, sad S. And then 7.01 divided by 1.98 gives us 3.54 meters per second. All right, averaging them up, I have this final speed box plus this speed box plus this speed box, and then dividing them by 3. I find that highlighting these boxes really lets me keep track of what I'm doing. So 2.19 plus 2.35 plus 3.54. All right, I get 8.8. I hit enter. I divide that by 3. And Nala's final speed on average is 2.69 meters per second. Oops. Meters per second. All right, so let's get all of this data on one table and let's see what we're left with. Drum roll, please. Now is the time to think back to your earlier predictions. Who do you think is fastest? Brooklyn, Reggie, Nala? Think back to what you said, and our results are in. Here they are, with a couple things for us to think about as we go. So on average, looking at my averages, that's my highlighter, right? Yep. On average, here's our averages. Brooklyn is the fastest, followed by Nala, and then Reggie. I can't say there's any surprises here. Reggie is highly motivated by food and not much else. So, here we go. So, fastest average is Brooklyn. Now let's look at who has the fastest overall time. Or the fastest overall speed in one instance. So, I should probably make that say fastest trial. Fastest trial. So, who had the fastest trial? I believe it was actually Reggie. So if I'm looking correctly, get my pointer out so I can actually screen. 1.4 or 2.11, 2.67, 3.03. Again, I'm looking for the highest number. He had the slowest trial for sure. But yeah, he ended up actually having the fastest trial as well. So I'm gonna put him in there as our fastest trial. And then this didn't quite meet my expectations. I thought for sure that, I don't know. I guess I expected Brooklyn and Nala to be pretty close, which I think they are. I did expect Reggie to be slower. Again, they are my animals or my family's animals, so I have a better sense of where they should be. One thing I noticed is with these having the highest and the lowest, his average ended up being pretty close to everyone else's. But yeah, so with that being said, this is like a completed version of your actual lab that you'll be doing. I will have all of the videos that I have shared in here, all the little skill videos included. But this is basically what you're going to be working through, and you're going to have a written summary section or a place that you can record like I just did to talk about why I think some of the things happened that did. I think if I were to have to get the cats to run that 7.01 meters, I think that Nala would be fastest by far because my cats do not have the attention span for that. All right, so here is a complete real life quarantine lab with results, data collection, and I'm really excited to see you guys get to do yours.